My name is Morgan Adams. This is my Nutrition Assignment 1 resubmission on nutrition and digestion. My student number is ADA 150000316. This is the recommended daily allowances of protein. The guidelines are that for an average sedentary man weighing around 70 kilograms, he should eat 0.8 grams of protein per kilogram of body weight that he has. Or as an alternative to this, he could eat 0.36 grams per pound of body weight that he has. So the calculation that you would do for anyone, you would take their weight and times that number by 0.8 grams, and in this case 70 kilograms times 0.8 grams is 56 grams per day, and that is the recommended daily allowance for this person in particular. And in general, people should be aiming to get 15 to 20% of their diet to be proteins. This slide shows the recommended daily allowances of minerals. First of all, we have zinc. 15 milligrams of zinc is the recommended daily allowance. Zinc helps to improve the immune system and fight off infections. The recommended daily allowance of calcium is 1000 milligrams. Calcium helps to build bones and keep bones strong. The recommended daily allowance of potassium is 3500 milligrams, and this helps to balance the fluid levels within the body. Sodium is 2400 milligrams, and this is to help with muscle contraction, to help the movements in the body. Magnesium's recommended daily allowance is 350 milligrams. This is to regulate nerve functions and muscle functions also. The recommended daily allowance for iron is 15 milligrams, and this allows the body to create oxygen carrying red blood cells to muscles. These 6 minerals will help the body to function properly, and will help sports people in a way that, for example, calcium will help a weightlifter as they have a lot of pressure on their bones. So it's important that they have a high calcium diet, as their bones will be weak without the calcium, and this can cause injury like broken bones or chipped bones. Also, iron is important for an athlete such as a marathon runner, as they help to create the bond between the oxygen and the red blood cells, and without the oxygen attached to red blood cells, there would be less oxygen which is sent to the muscles when working, meaning that we cannot work for as long. So the more iron is in the body, the more oxygen will attach to red blood cells, and that is a benefit of eating or getting this much of this mineral. Now we have the recommended intakes for sports performers. I've chosen to compare a weightlifter and a marathon runner. First of all, I'll look at a weightlifter's recommended diet. First of all, I've given them 40% of carbohydrates, 15% of fats, 30% protein, 5% fiber and water each, and 2.5% vitamins and 2.5% minerals. I've chosen this because as a weightlifter, you'll be working a lot with high intensity exercises, and you'll be tearing your muscle fibers as you're lifting weights. So the muscle fibers need to repair quickly in order for you to train on those again. And the more protein that you have, the quicker and more effectively your muscles will repair. And this is important because they can then train harder the next day and improve their weightlifting capabilities, allowing them to get a better score in events like deadlift. I've given them 40% of carbs because although they won't use their carbs as much because it's a high intensity, short period of time exercise, they still need carbohydrates as any normal person does because it's the main source of energy. Also, it's important to drink a lot of water as a weightlifter, so I've given them a decent amount of 5% of energy, and also the vitamins and minerals that I've already spoken about. So, for example, calcium is important because it reduces the risk of bone injury in particular. The effects that all of these nutrients have on sporting performance is that this is the recommended amount, just so much so that the 30% of protein will allow them to recover quickly for their next event or their next day of training. The carbs will keep them ticking over throughout the day and throughout their training sessions. And also their fats are good because they'll be able to burn those throughout the day as well. Next up, we have a marathon runner for the recommended daily intake. As you can see, I've given them a higher percentage of carbohydrates, as their exercise is low intensity, but it lasts for a long period of time. So they'll be using a lot more long-lasting energy than the weightlifter. It's important for them to get their immediate stores of carbohydrates and then stores that they can use later on in the race. So in the last mile or two that they're running, they still have enough energy to do a sprint finish in the last, however many, like 100 meters or 200 meters. I've given them less protein because although their muscle fibers are tearing as they're working out, it's not as much as the high intensity of the weightlifter, because it's a fairly non-weight bearing exercise of just running. Also, I've given them 5% of water. They need to keep their fluid levels high as they're running because they'll lose a lot of sweat through running and working out. Again, I've given them 2.5% of vitamins and minerals, and I've given them 5% of fiber, and the recommended daily intake of fiber is 18 grams. And this is good to help their digestion, to prevent them from feeling bloated throughout a race, to allow them to really work as hard as they can for a long period of time. The effects on sporting performance are that, as I've said, the high percentage of carbs will last longer throughout a race and through training, so they can train harder, which means that they can finish in a quicker time in the race because they can use their energy more effectively in the later stages of the race. Water is important, as I said, because they'll lose a lot of water through sweat, so they need to replenish those water stores. Next up, we have the digestive system. The digestive system is the system in which we eat and process our food and get our energy to our body. The digestive system starts with the mouth. The mouth is used to grind down the initial stage of the food and add saliva to the food. The saliva includes an enzyme called amylase. This helps to break down the starchy products. This food is then passed through the esophagus. Peristalsis is the action that happens within the esophagus to squeeze the food down through to the stomach. Peristalsis is a wave-like motion of muscles contractions, and when the food gets into the stomach, the stomach is used as a mixing bowl, so the food will be churned up into a liquid called chyme. The stomach then releases a digestive enzyme and also hydrochloric acid. This helps to kill bacteria and digest food. The chyme that was made in the stomach then passes through the duodenum into the small intestine. In the small intestine, there is a lot of digestive juices released from the pancreas, and this fluid helps to break down further any foods that are still not broken down. Mainly carbs, fats, and proteins are broken down in this stage of the digestive system. There is a concentrated bile that is stored in the gallbladder. So the gallbladder will release the bile into the small intestine, and this helps to break down those foods and get them into our system, into our limbs, which will help with our energy usage in sports. Also, there is a villi line which lines the inside of the small intestine, which absorbs the vitamins, minerals, amino acids, and the sugars, which are all found in the small intestine. Then, from the small intestine, the chyme reaches the large intestine, which is mostly fluid and indigestible matter at that stage, because the small intestine is sort of the last stage of the digestion, whereas the large intestine is more just passing through the already churned up foods through to the rectum, and then the indigestible matter, which was the food at the start, turned into chyme, and now the indigestible matter is excreted through the anus. That is the summary of the digestive system. I'd just like to add that the main three functions of the digestive system is first to digest, secondly to absorb, and thirdly to excrete. So as you can see, the digestion phase happens at the mouth, the stomach, and the small intestine mainly, with the help from the pancreas, the gallbladder, and the esophagus all pushing through the food and adding bacteria, killing enzymes to break down the food further. The absorption phase is through the villi line, which is the line of the stomach walls and the small intestine walls that absorb the minerals, the vitamins, and the sugars. And then the excretion is after the large intestine will push through the indigestible matter into the rectum and out of the anus. Also, I'd just like to add the stage of which this happens. It goes through the mouth, then the esophagus, the liver, the stomach, the gallbladder, and the pancreas, through the duodenum, through the large intestine and the small intestine, out of the rectum, and then the anus. That is the end of my slideshow. Thank you for watching.